This video is on integral word problem review, so it's more of a cumulative review of multiple topics. So yeah, let's get right into it. So here is a word problem. So basically you're given two functions. One function is represents the rate at which the water is being filled in cubic feet per hour, and then the function h of x is a function that represents the rate at which water is being drained out of the tank. Okay, so given that it took 30 minutes for the tank to reach the height of 30 feet, find the amount of water drained from the tank in that time. So given that t equals 0 at like the beginning, we're going to say amount of water drained equals 0 to 0.5, right? Because this is in terms of hours, and then 30 minutes is 0.5, and then h of x, right? H of x dx. Okay, so this is basically the point in time when we can use our graphing calculators. Okay, so for the amount of water drained from the tank in that time, I got around 2.13. So 2.130, and then this is in hundreds cubic feet, right? So around 2.130 hundreds cubic feet of. Okay, so I graph the solution, or like the problem, on our graphing calculator in Desmos. And then what you do is basically you do y equals, you have to set the integral into y equals, and then you have to do 0 to b, a certain interval. I know I used a right here, but then I just used b here. And then there, you put in the function h of x dx, and then you also put in a line, y equals 200, and then you graph these, and then you find out the intersection point. So the intersection point would be right here, right? The intersection point between the two functions would be right here. So at 5.291, when a is around 5.291, then the volume of water that was drained from the tank would be 200. Okay, so for part C, it's no longer about the change in the amount of water in the cylinder. Now it's actually the amount of water in the cylinder. So what we have to do is a little bit more than what we did before. So volume at t equals to 4 is going to be equal to, from 1 to 4, right, of f of x minus h of x, right, dx. And then this makes sense, right, because when we take the derivative, or not the derivative, when we take the integral of f of x, we're getting the amount of water filled into the tank from 1 to 4, right? And then we're subtracting that by the amount of water drained from the tank from 1 to 4, which is the integral of h of x, right? So that makes sense. And then what we're going to do is to add the amount of water already in the tank by t equals to 1, which is going to be given by v when t equals to 1 is going to be this equation. So pi times 12 is the radius times the height, which is going to be 30 at t equals to 1, right? Because t equals to 1 is the point in time where the cylinder height level reaches 30 feet. So this makes sense. So we get 360 pi as our volume when t is equal to 1. So we're going to add 360 pi to see how much water is actually in the cylinder by t equals to 4. So this is when the graphing calculator comes in. So 1.755771 cubic feet of water is in the tank by 9 a.m. So for number 2, we're supposed to use the Lefferts sum to approximate the number of teddy bears made, right? Since we're given the rate of teddy bears made, we have to take the integral to find the number, or the amount of teddy bears made in that time. So we can say it's from 0 to 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So 6. of s of t dt is approximation going to be, first try to visualize the left Riemann sum, 1, 2, 3, 4, 5, 6, right? And then left Riemann sum right here, left Riemann sum right here. Right, okay, so we have s of 0 plus s of 2 plus s of 4 times 2, right? Each width is 2. Okay, so that's going to be 2. We're going to say that's equal to 56 plus 367 plus 672, all multiplied by 2. Okay, so we're going to use our calculator. 56 plus 367 plus 672. We get 2190 teddy bears. Around, or you can say approximately, 2190 teddy bears are made. Alright. Alright, so we are given s prime of t equation, so we're supposed to find s of t from that. So we'll be using integration techniques. And as you can see, we can't really use substitution because the conditions are not met, so we'll be using integral by parts. So integral of s prime t dt is going to be equal to u equals 5,000 t, du equals 5,000 dt, dv equals e to the t, v equals e to the t, right? So we're going to say s prime t, which is going to be equal to 5,000 t e to the t minus 5,000 and then et dt, right? So that's going to give us 5,000 t to the t minus 5,000 e to the t plus c. One thing we have to make sure is that since we have 1 and 0 as s of t value, when we plug in 1 to s of t, we're going to get 5,000 e minus 5,000 e. Right, that's going to be equal to 0. And plus c is going to be equal to 0, so c is going to be equal to 0. So s of t is just going to be 5,000 t e to the t minus 5,000 e to the t. Okay, so this will be our s of t function. And then it says to find a value c which will satisfy the mean value theorem on 0 to 4. So this means that we have to do s prime of c is going to be equal to s of 4 minus s of 0 all over 4. And then looking back, s of 4 was 672 minus s of 2, which is going to be 367. Oh, s of 0, which will be 56, all over 4, right? And then for that value, we got the answer of 154. So s prime c is going to be equal to 154. So I used my graphing calculator, and then I graphed the function for s prime of t, and then I also graphed a line. Y equals 154, and then I found the intersection of those two functions. Okay, and then for that I got the answer of 0.03. Yeah, so at 0.03, the function will satisfy the mean value theorem. It says, given that s of t equals integral of 0 to t from 6 sine to the third 5t, What's the meaning of s of 1 in the context of the problem? Find the value of s of 1. Okay, so s of 1, if we plug in s of 1 here, then it's going to be 0 to 1 of 6 sine to the third 5t dt, right? So this means that in the context of the... So to find out the value of s of 1, we have to use trig integration techniques. So 0 to 1, 6 sine third 5t dt. So that's equal to 6 times 0 to 1 of 1 minus cosine squared t, or 5t, times sine 5t, right? Okay, so we're going to set our u as cosine 5t. du is going to be negative sine 5t, and then times 5, right? And then dt. So negative 5 sine 5t dt, and then du equals, so negative 1/5 du equals sine 5t dt, which we have right here. So we're going to plug it in. So this is equal to negative 6/5 times 1 minus u squared, right, times du, right? Okay, so we have negative 6/5 u minus 1/3 of u to the third power. Okay, and then instead of 0, 1 here, we were supposed to put our changed interval. So here we have changed interval. So plug in 0 to cosine 5t. That's going to give us 1, right? 1, and then we're going to get cosine 5. Okay, so cosine 5 and a 1. Okay. So we're going to get negative 6/5, and then cosine 5 minus 1/3 cosine 5 to the power of 3 minus 1 minus 1/3, right? Okay, so negative 6/5 times cosine 5 minus 1/3 cosine 5 to the power of 3 minus 1, or minus 2/3. Yep, so this would be our answer. Plug it into your calculator and you'll get the full answer. And as for the value of s of 1, I'm getting about 0.469. Okay.